Alright guys, so for a quick review on thermodynamic processes, we're going to talk about isobaric, isovolumetric, isothermal, and adiabatic processes and what you need to know for the quiz. So we'll start with isobaric. We'll take a look at our PV diagram and the first law of thermodynamics. And isobaric, iso meaning same, baric meaning pressure. Think of it like a barometer. Means that the pressure remains constant. So on your PV diagram, if you have constant pressure, just a straight line across the x-axis. So if that's true, then the work done by this gas is equal to negative P delta V. And in other words, if you're multiplying P times V, or your y-axis times your x-axis, that just means find the area under the curve. Okay. Now the first law stays pretty much the same as it is. There's really no changes there. The important part is that the work done by or on the gas is this area here under the curve. So isovolumetric process is a little bit easier to remember. The volume stays the same, so that would be a line straight down. And if we're looking at that, then the work done here, because delta V is 0, the volume doesn't change, is also 0. Which means all that we're left with is that the change in internal energy of this gas is equal to just the heat added to or removed from that system. Okay, so that's the two straight lines on your PV diagram. The next two we're going to look at are isothermal and adiabatic. Okay, isothermal and adiabatic are two that people tend to get confused a lot. Isothermal means the temperature remains the same. I guess a good way to remember that might be to look at this T here at the beginning of thermal and just imagine that that T stands for temperature. So if the temperature stays the same, that means there is no change in temperature. So we set that at 0. And if that's true, and energy or temperature is really just a measure of energy, that means that delta U is also 0. From our first law, all that leaves us with is Q is equal to negative W. And that means that whatever work you do on or by the system is canceled out by the heat that enters or leaves the system. And the way this looks on a PV diagram is actually a curve. Call that an isotherm, and that represents one specific temperature. So for example, this might be 200 Kelvin. Okay? And anywhere along this curve, the temperature of this gas is 200 Kelvin. So at a different temperature, we would see the same shape, but it would be a little bit higher, so that could be something like 300 Kelvin, or 400 or 500, whatever. Okay, so that would be called an isotherm, and that just represents an isothermal process where the temperature does not change, and therefore the internal energy does not change. Last one is adiabatic, and in an adiabatic process, no heat enters or leaves the system, so Q is equal to 0, and all that leaves you with is the change in internal energy is equal to now just the work done on or by the gas, whether that's negative or positive depends if it's on or by the gas. And what that would look like on our PV diagram is, well, if we're doing work on the gas and heat is not allowed to leave the system, what that means is the temperature is going to increase. It's not going to be a straight line, however, because it's not isobaric and it's not isovolumetric. So an adiabatic line on a PV diagram actually curves from one isotherm to another isotherm, so it would look something like this. And it would connect the two isotherms. And you could have another one further down there. Okay. And if this were a process here where we have 1, 2, 3, 4 steps in this process, and we're taking a gas through all those steps, and you were asked to find the net work done in this process, all you would need to do is find the area under that curve. Now with curved lines like this, you're not going to have to do that. That would involve calculus and integration. The only thing that you'll be asked to do or required to do would be some kind of straight line, where you could just find the area of a triangle, which would be 1/2 base times height. Okay, so that is all 4 thermodynamic processes and the first law of thermodynamics. The things that I'm going to ask you to know are what each one means in terms of the first law, what each one holds constant, so pressure, volume, temperature, and no heat added or leaving the system, and also what each line looks like on a PV diagram. So again, this would be isobaric, this would be isovolumetric. We have these isotherms here for isothermal. And finally, adiabatic would connect to isotherms. Okay, and those are all the things that I'll be asking of you on the quiz right when we return from break, and also on the midterm during midterm week.